Welcome back to the workshop. We want to continue taking a look at section 9.4, the one mean z-test. Let's take a look at our notes. All right, so we already talked about the procedure 9.1, and we would like to take a look at an example of it. We want to apply the procedure. So we're considering an example where Eric believes he can throw a frisbee on average more than 32 yards. So he collects the following 34 observations to test this. Okay, we're going to perform our hypothesis test. So at the 5% significance, do the data provide sufficient evidence to conclude that the mean distance Eric can throw a frisbee is greater than 32 yards? Okay, we're going to assume the population standard deviation is 3. Excellent. So in order for us to use this, we need to make sure that the data set satisfies those guidelines that are given on the previous slide. And we already saw this exact same data set back in chapter 8. So we've already verified that there are no outliers, and we've already verified or computed what the mean is. However, just to be thorough, what I'd like to do is I would like to take a look at this anyway. So a couple things that we want to do, or that we could do to check for outliers, is we could take a look at the QQ plot, which is the normal probability plot. And we do that for the sample size 34, because that's the one we're working with here. And I think that's all that we need there. So we hit compute, and we can see that there's nothing that's crazy far off the line. So we say, all right, thumbs up. There are no outliers. Now, if you wanted to, you could also go ahead and find a, let's see here, box plot. There we go. I believe that's the one I want. And compute. Yep, there we are. And there's no dots or asterisks or anything like that. So yeah, we're good to go. No outliers. All right, in our computations, we are going to need the mean of the sample. So we should also find that. So we want to find a summary statistic of the column of size 34. There we go. And all that I'm really interested in is the mean, but maybe it's good to double check how many are in there. So check the mean is the size and the mean, compute, and here we are. We have size 34 observations there, and the mean is 34.1. So we have all the information we need then in order to move forward in our computations, assuming that we get through the assumptions. So let's take a look at those. All right, the assumptions are that it's a simple random sample, a normal population, and that the standard deviation is in fact known. And we do have those things. So we want to make sure that we state it as well. So let's move back to our example here. And what I'd like to do is I'd just like to make sure it's clear what we're doing here. We are using procedure 9.1. 9.1, which is the one mean z-test. Excellent. And the first thing we need to do is verify the assumptions. All right, so the assumptions. The first assumption is that it is a simple random sample. So do we have, in fact, a simple random sample? And we're going to say, yes, we do, or close enough. All right, the next assumption was if it's a large sample or that the population is normally distributed itself. So in this case, do we have a large sample? And we'll say yes. And the size of that sample is 34, which of course is greater than or equal to 30. Right, 30 is the standard for large, or relatively large anyway. The third assumption, again, is that the standard deviation of the population is known. And in this case, we're saying, yes, we're working with the assumption that the standard deviation of the population is 3. So we're given each of these things. Now that we have that, we say thumbs up, we can move forward using the procedure. So step 1. Step 1 is to state the hypotheses. So we want to state the null hypothesis, which is always a statement of equality. And let's go back to the directions for the example to just make sure we know what numbers we're working with. All right, so Eric believes he can throw a frisbee on average more than 32 yards. So 32 is the magic number in this case. And he believes he can throw it more than. So mu is equal to 32 is the null hypothesis because the null hypothesis is always a statement of equality. Then for our alternative hypothesis, it's the conclusion that we would like to draw, that Eric can throw the frisbee more than 32 yards. All right, step 2 is to decide a level of significance. And when we decide a level of significance, sometimes we're going to decide it for ourselves, such as a statistical project. But in this case, it's given to us. If we refer back one more time, we're working with 5% significance. 5%. So alpha is equal to 0.05. Step 3 is for us to compute the test statistic. Now, for us to compute the test statistic, we're going to need to know a few things. So we need to know what the mean of the sample is, and we found that to be 34.1. How many observations are in the sample? We found that to be 34. And the standard deviation of the population, we already knew. We said that up here, that's 3. But that is essentially it. The only other number we need is this number here. So Z naught is equal to X bar minus mu sub naught, the proposed mean, divided by the standard deviation of the sample means. So this is the standard deviation of the population. This is the standard deviation of the sample means of size n. So that gives us 34.1 minus 32 divided by 3 divided by the square roots of 34. Now for this, we can just go ahead and punch that into our calculator and find that that is 4.08167. Now on table 2, we only have up to 2 decimal places for z values. So we might even say that this is approximately 4.08, having rounded appropriately. Okay, and we'll use that to find our critical, to find our p-value in the p-value approach. All right, so that's the first 3 of 6 steps. So we move on to step 4. And step 4 is different for the 2 different approaches. So I'm going to split these up, the page up here a moment, so that way we have the critical value approach. So the critical value approach and the p-value approach. Now, of course, when you're working through these things, you don't need to provide both approaches. You just need to provide whichever one is requested. That's all. So I want to show you both. I want to make sure that you are aware of both. So I'm showing you both, but that would not be the expectation. The expectation is that you're capable of doing one of these at a time. All right, so step 4. Step 4 in the critical value approach is to find the critical values. Find the critical values. So since we're looking at a right-tailed, let's double check this. And actually, it's a good thing to make note of that. What are we looking at? It is a right-tailed test. Excellent. Right-tailed test. So what we want to do is we want to find the z-value, which has an area of alpha to the right. So z sub alpha is z sub 0.05, which we've computed a few different times in the past, and we should hopefully be familiar now that this is 1.645. If you weren't sure of that, you can find this on the on table 2, and I do have that here. We'll reference that shortly for the p-value approach. Okay, so we have step 4 for the p-value approach, and then step 5 for the critical value approach. Step 5 for the critical value approach is to make the decision. Of course, that's the same step for the p-value approach, but we make our decision a little bit differently. In this case, we compare our test statistic to the critical value. And what we're going to find is that Z naught is equal to 4.08, which is greater than 1.645, which is Z sub alpha. And when Z sub naught is greater than Z sub alpha, we want to reject the null hypothesis, right? This is for our right-tailed test. Our Z value is higher than the critical value. So we did find something that's high enough, that's enough larger than the proposed mean to decide that it's probably, the mean is probably actually larger, okay? So we should find the same decision over here in step 5 for the p-value approach. But here what we need to do is to find the p-value. And so what we're going to do here is we're looking for the probability of finding something that's even further away from the mean, the proposed mean, than what we found. So what I'm saying there is here's what we found, here's the mean, it's normally distributed, what's this area? That's what we're looking for here. So in order to do that, P in this case would be 1 minus the area to the left. The area to the left is given in our table 2. So I just need to find 4.08 on this table. That gives me the area to the left. I take 1 minus that area, and that's the area to the right. So, okay, excellent. So 4.08, negatives, positives. Oh man, it stops at 3.9. So the area to the left is 1.0000. And that's actually not quite exact. That's just what it is to 4 decimal places when you round it at 4 decimal places. So we say it's approximately 1. Excellent. That means that what we end up with, let's see, is 1 minus 1, which is 0 for the p-value. So step 5 is again the decision. And we find that p is equal to 0, which is less than 0.05, which is equal to alpha. So p is less than alpha. And whenever p is less than alpha, whenever we decide to reject the null hypothesis. Excellent. So we have the same conclusion. And then step 6 is to interpret the results. Now, to help make sure you can read this, I'm going to type this in. Let's go a little bit bigger yet. Here we are. Hey, that looks great. All right, so we should be very thorough and very clear in our interpretation. Now remember, our test is about whether we are rejecting or not rejecting the null hypothesis. Our conclusion, right, our interpretation is with regards to the alternative, the thing that we may have wanted. Okay, so at the 5% significance level, the data provide sufficient evidence to conclude that on average, Eric can throw a frisbee more than 32 yards. So if we had actually not rejected the null hypothesis, then we would have said at the 5% significance level, the data do not provide sufficient evidence to conclude this. Okay, excellent. So we've got one more example to take a look at. And the next one will be a little bit different. It's very similar, of course, using the same data set. So it's very similar to try and make things as easy and quick as possible, but it's a different test. So for now, thank you for joining me, and I'll see you back in the workshop very shortly.